This is 3-1 graphing relationships. So the first thing you'll have to be able to do in 3-1 is choose a graph that best represents the situation. So you'll be given a word problem such as the air temperature was constant for several hours at the beginning of the day and then rose steadily for several hours. It stayed the same temperature for most of the day before dropping sharply at sundown. So we're trying to figure out which graph represents this situation. And here's some key words that you can use when looking at a graph. You read the word problem, you find these keywords, and then you can see if the graph matches what's written here. So for instance, at first it said the air temperature was constant. Well, what that means, if we look at our temperature, it should be at a horizontal line. And then it's rising steadily for several hours. It should be slanting upward for rising steadily. It stays the same. That should be a flat rate. So we're looking for something that rises and then is flat. It stayed the same temperature for most of the day before dropping sharply at sundown. So dropping sharply would be like a sharp graph going down. So like B drops quick, and so does C. But you have to make sure everything else matches. So let's see, the air temperature was constant for several hours. So over time, it was constant. Then it rose steadily. Then it stayed the same temperature. And then it dropped sharply. So the keywords in this graph will help you to know which image you should be selecting that best represents the situation. There are two types of graphs. There's continuous graphs and there's discrete graphs. Now you want to use the beginning of each word to help you remember this. So discrete begins with D and continuous begins with C. So with continuous graphs you connect the dots. So it would be something like that. With discrete graphs, you just have dots as demonstrated here. There's no in between. And it makes sense because you're not going to have halves here. We don't have half a person. Where it says number of people, you won't have a half of a person. So therefore it's a discrete graph. It's made up of a bunch of dots. A continuous graph would go on and on forever. So for instance, like on the y-axis, the people, if it was 2.2, well, you wouldn't have 2.2 people, so that doesn't make sense. So what's important here is that you know that continuous graphs would have connected dots, and discrete graphs just have dots. Discrete dots, continuous connecting. So think of the first letter of each word. So Simon is selling candles to raise money for the school dance. For each candle he sells, the school will get $2.50. He has 10 candles that he can sell. So candles sold. Can you sell 1.5 candles or 1.25 candles? Seems silly, and so since it's not including the numbers in between 1 and 2, and 2 and 3, and 3 and 4, then it's just the dots themselves. They don't include those numbers. So the dots show that this graph is discrete. Okay, if you were describing this without even reading any of what's happening here, we're going at a constant rate here, rises steadily, constant again up at this flat rate, drops quick, and then constant.